Hello everyone, welcome back to my YouTube channel. Today I will be sharing some knowledge with you about the solar system, and today I will be sharing knowledge with you about the sun. This is the sun. It's very beautiful and it has lots of different features on it. But what exactly does the sun have? So first, there is the convective zone. It's just under the sun's surface, and it's a space where pockets of hot gas rise, cool, and then sink back down again. This movement helps carry energy from the core and toward the surface. The sun's core is basically just like a nuclear reactor. The nuclei, which is basically another name for the centers of the hydrogen atoms, are forced together to form helium nuclei. That is called nuclear fusion because they are forced together and they're fusing, so that's why it's called nuclear fusion. So there is another feature on the sun which you can see pretty clearly in this image, which are sunspots. Sunspots are these darker areas of the sun which have slightly lower temperatures than the average sun surface. It's only about 3,500 degrees Fahrenheit, which is 2,000 degrees Celsius, cooler than the rest of the surface. Well, 2,000 degrees Celsius cooler, which is also 3,500 degrees Fahrenheit cooler. That's already a lot of temperature. Its surface temperature is its surface temperature is 5,500 degrees Celsius, which is 9,930 Fahrenheit. That means if it's 2,000 degrees Celsius cooler, it's 3,500 degrees Celsius, and if it's 3,500 degrees Fahrenheit cooler, then if the sunspots are 3,500 degrees Fahrenheit cooler than the average surface temperature, that means that it's 9,930 minus 3,500, which is 6,330 degrees Fahrenheit. So it's still very, 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 very hot, but it's still less temperature than normal. So there is another zone which is beneath the convective zone, which is called the radiative zone. It's deep beneath the convective zone. It's very dense, it's very hot, and energy travels through this part of the sun as radiation. There is small jets of gas coming off the sun, which you can see in this part of the picture, and they're called spicules. So they are basically just jets of gas that cover the whole entire sun. The outer part of the sun is called the photosphere. It's transparent to light, which creates the illusion of a surface. This apparent surface is the photosphere. It has a grainy appearance, as you can see over here. It's covered with sunspots and it just looks very grainy because there's different parts of the sun that radiates more heat, and there's different parts of the sun that radiates less heat, which causes it to have different surface looks. The core of the sun is 15 million degrees Celsius, which is 27 million degrees Fahrenheit. That is, if you compare that to the boiling temperature of water, which is 100 degrees Celsius, it is a lot. Now for the speed of light section. It takes 8 minutes for the sun's light to reach the Earth, which means that it will take 8 minutes for us to know that the sun exploded, if it did. And while it only takes 8 minutes for the sun's light to reach the Earth, it takes 100,000 years for the sun's energy to reach from the core to the outside, to the photosphere. And while the sun creates light for us, it produces streams of high energy particles forming the solar wind. It's very deadly, and it also creates northern lights. Earth's magnetic field protects us from these particles like a cage, but then if a strong blast of them disturbs the magnetic field, trapped particles come down into the atmosphere, which set off brilliant light displays near the poles called auroras, or the northern and southern lights. The sun weighs 2 billion tons, which is very heavy. 2 billion tons is already very heavy. Multiply that by another billion, which is very, very, very heavy. And multiply that by another billion, which is very, very heavy. So it's a billion has 12 zeros. So that's 10 to the 12th power. If you want 2 billion tons, that's 3 billions, that's 36 zeros. So that becomes 2 times 10 to the power of 36 tons. 1 ton is 2,000 pounds, to put that into perspective. So in conclusion, our sun is very, very, very amazing, and it has lots of features that is hidden inside it, and there's also lots of features that can be seen with special types of telescopes, but those features are usually very hot, such as a solar flare. A solar flare is just like these, and these. These are all these are solar flares, and these are spicules. The spicules stay near the surface, while the solar flares fly off. So solar flares are quick eruptions of radiation that happen a lot in the sun. If you take Earth's mass, change that into 1, and you compare the sun's mass with the Earth's, it's 333 times more. As you can see over here, there are loops of hot eruptions, and they are not spicules. They are actually called prominences, and they are giant eruptions of hot gas, usually bursting from the sun. They aren't solar flares because those eruptions of hot gas don't fly off like these. So in conclusion, the sun is a very large star that is made up of mostly super hot hydrogen and helium gas. And there's 3 zones of the sun, which is the radiative zone, the convective zone, and the photosphere. The photosphere is transparent, therefore creating a grainy texture that looks like a surface, but it actually isn't a surface. The convective zone is below the photosphere, which is an area where hot gases rise, cool, and sink back down again, which lets energy go toward the surface. And the radiative zone is very dense and very hot, and energy travels through this part of the sun as radiation. And the energy takes 100,000 years to get from the core to the surface and 8 minutes to get to Earth. So this is it for today. Thank you for watching this video and stay safe. Bye.